All right, let's look at one more example of an indefinite integral involving an exponential function. So here our exponential function is in our integrand is e to the cosine x, right? So I think it should be, I think or I hope it should be pretty obvious to you by now what sort of substitution we're going to make in this integrand. We're going to let u be equal to cosine of x. And so du dx is going to be equal to minus the sine of x. And then when we solve this for dx, I think we'll get dx is equal to minus du divided by sine of x. All right, so now let's actually do our substitutions. So we can't substitute anything immediately for sine of x, but of course for cosine of x, we're going to substitute u. That's our basic substitution. And then for dx, we know that dx is equal to minus du over sine of x. And so good things happen here, right? Just like we had hoped. The sine of x's are going to cancel. This minus sign we can factor in front of the integral because that's a constant. So we have minus the integral of, again, just our basic exponential function, e to the u, right? And so easy to integrate that. That's the great thing about exponential functions. And so we get our antiderivative is just minus e to the u plus a constant. And now let's undo our substitution. So we just have to substitute for u, cosine of x. So here's our antiderivative. It's minus e to the cosine of x and then plus the constant.